Some equations simply can't be solved directly. You have to learn how to convert between different formulas. Take this problem, for example. If you try to solve it head-on, you won't get anywhere. Let's take a look. You're given that x plus y equals 1 and x squared plus y squared equals 11. Now you're asked to find the value of x cubed plus y cubed. Can we actually solve for x and y from this system of equations? Of course you can solve for them, but the solutions involve square roots and get really complicated. The answer is very complex, and if you substitute it back in, the calculations become so messy that you can't even finish them. So what should you do when you see equations like this? You must learn how to convert between different formulas. When you see something like the sum of cubes, isn't that the sum of cubes formula? Isn't it equal to x plus y times what? X squared minus xy plus y squared. Isn't this the sum of cubes formula? You know it's equal to that, and you also know that x plus y equals 1. So isn't that just 1 times x squared plus y squared? And don't you know that's equal to 11? So it's just 11 minus xy, right? In other words, for this expression, I don't need to know the exact value of xy. As long as I can find xy, that's enough. So how do you find xy? Can you use these two equations to figure out what xy equals? Isn't this just the square of x plus y? What does that equal? It's just x squared plus y squared plus 2 times xy, right? That's the perfect square formula. What does x plus y squared equal? It equals 11. What is x plus y squared equal to? Isn't x plus y equal to 1? Isn't it 1? So 1 equals 11 plus 2xy. Right? So what does xy equal? Isn't 1 minus 11 equal to negative 10? Isn't that negative 10? If it's negative 10, what does xy equal? Doesn't xy equal negative 5? If xy equals negative 5, substitute negative 5 into 11 minus negative 5. Doesn't that give you 16? So the answer is 16, right? In the future, when you encounter equations like this, you must learn how to convert between these formulas. Everyone.